Today, we're talking about a technology that is quite literally all around you. It's running in the background of your navigation app, it's helping your city plan for the future, and it's on the front lines of global disaster response. It's called GIS, or Geographic Information Systems. And let me tell you, it's about way more than just making pretty maps. Let's dive into how it really works. So to really get a handle on just how powerful GIS is, let's start with a puzzle. Why on earth would an entire country, in this case Kazakhstan, decide to completely scrap its official maps and start over? I mean, that sounds like a massive undertaking, right? Well, the answer gets right to the heart of why this technology is so crucial in our modern world. So get this. For decades, the country was running on a mapping system from 1942. Now, not only was it ancient from a tech standpoint, but it was also classified, a relic of a bygone era. This meant that all this critical geographic data, the very blueprint of the country, was locked away. Businesses couldn't use it, developers couldn't access it, and investors were flying blind. It was like trying to build a modern economy with one hand tied behind your back. And the solution to that problem? GIS. So what is it? Well, at its core, a geographic information system is basically a smart map. It's a whole framework designed to handle any data that's tied to a location. It doesn't just show you where things are, it's built to help you understand why they're there by collecting, storing, and most importantly, analyzing all that location-based information. Okay, so how does GIS actually take our messy, complicated, three-dimensional world and turn it into something a computer can understand? Well, it boils it all down to two fundamental ways of seeing things. You can almost think of these as the basic DNA of any digital map. These two models are called vector and raster. On one hand, you've got vector. It sees the world as a collection of separate, distinct objects. It uses points to represent something like a fire hydrant, lines for roads or rivers, and shapes or polygons for things with clear boundaries like a building or a country's border. On the other hand, you have raster. Raster sees the world as a seamless grid of tiny cells, or pixels. Each pixel has a value, maybe its elevation or temperature, or what kind of vegetation is there. It's perfect for stuff that's continuous and doesn't have sharp edges, like a satellite photo or rainfall patterns. And here is what that actually looks like. See on the left, that's the vector model. See how crisp and precise those boundaries are? It's all about defining individual things. Now look to the right. That's the raster view of the same place. It's a continuous surface made up of pixels. So you have two totally different ways of digitizing the same spot. One is focused on objects, the other on surfaces. But here's where the real genius of GIS comes in. It's not about choosing one or the other. The real power is unlocked when you start organizing all this data, both vector and raster, into layers. Imagine you have a stack of transparent sheets. That's exactly what this is like. And here you can see that idea in action. You've got one layer that's just the roads. Another layer on top of that is just the buildings. Then maybe you add another one for zoning or parks. Each layer is just one piece of the puzzle. But when you stack them all together, suddenly you start to see connections and patterns that were totally invisible before. So we know what GIS is, but what can it really do? Well, this is where we get to its true superpower, spatial analysis. This is the part where we stop just looking at the map and start asking it questions. This quote just nails it. A regular map, a paper map, it can answer a simple question. What is here? But a GIS, it can answer incredibly complex questions, like show me all the houses for sale that are in a good school district, but not within a quarter mile of a noisy highway. It's a tool for finding exactly what you're looking for. Let's look at a really common tool. It's called buffering. See those colored bands along the roads? Those are buffers. They're zones created at a very specific distance from the road. With these, a city planner can ask, instantly, how many parks are within the green zone? Or, are any sensitive wildlife habitats in the red zone? It's a simple idea, but it's an incredibly powerful way to analyze what's near what. But wait, it gets even better, because the real magic happens when you start combining these kinds of analyses across all those different layers we talked about. This is called an overlay. You're not just looking for one thing anymore, you're looking for the sweet spot, where multiple conditions all exist in the same place. Okay, let's walk through how this works to create a brand new insight. First, we start with a couple of layers, one showing the river basin, another showing the local geology. Then we add or overlay another layer showing where all the farms are. And finally, we tell the GIS to combine them and find only the spots that meet all our criteria, places with soil that water can easily pass through, that are also inside a farming zone, that are also within the river basin. And what's the result? A totally new map. This map shows the exact high-risk zones where pesticides are most likely to seep into the groundwater. That's not just data, that's a life-saving insight created from scratch. So now that we've seen a little of what's under the hood, let's zoom back out. Where are these tools actually making a difference in the real world every single day? Well, the applications are everywhere, seriously. Emergency responders use it to map flood zones and wildfires. City planners use it to figure out the best spot for a new school. Farmers use it for precision agriculture, optimizing every drop of water. Businesses use it to figure out where their customers are and how to reach them. Logistics companies use it to find the fastest delivery routes. In every single one of these cases, it's about using location to make smarter, better-informed decisions. Take a hurricane, for example. GIS isn't just a static picture, it's dynamic. It can track a storm's path, its changing intensity, its speed, all over time. This analysis lets emergency managers predict where that storm is heading next, so they can issue targeted warnings and tell specific communities to evacuate. This saves lives, plain and simple. And we're not just stuck in 2 dimensions anymore. GIS has gone 3D, allowing us to build these incredible digital twins of our cities. Planners can now visualize how a new skyscraper will cast a shadow over a park or see how a proposed subway line will actually connect to the streets above. They can even simulate things like airflow or floodwaters. It's a whole new playbook for designing smarter, better cities for us to live in. So, when you put this all together, the data, the layers, the analysis, what's the big picture? Where is this all taking us? The bottom line is this: GIS has completely changed the game. It's taken the map, which used to be just a static picture, and turned it into a dynamic, interactive database you can ask questions of. It's not just a tool for geographers anymore. It's a new lens, a new way of seeing all the hidden connections that shape our world. And that really brings us to a final thought. Our entire world is woven together by location, by geography. The spread of an idea, the perfect spot for a new business, the migration path of a whale, it's all spatial. Our world is just bursting with these hidden patterns. So I'll leave you with this question. With a tool this powerful in your hands, what would you map?